Hello geometry students, Mr. Cruzado here. Today's learning target is to talk about the Pythagorean Theorem. So if you look at a right triangle, across from the 90-degree angle is always called the hypotenuse. And the other two sides, let me fill this in first. The other two sides are called the legs. So there are two legs here. And Pythagoras, and there's a little history paragraph right here, learned this back in 1550 BC, and he learned that a squared plus b squared was equal to c squared, provided you had a right triangle. So this only works in a right triangle. Again, across from the 90 is the hypotenuse, and the other two sides are called the legs. I often write this in words: leg squared plus leg squared is equal to hypotenuse squared. I'm going to move this over a little bit. And here's a quick visual proof of that information. So if you look at the right triangle here, the yellow right triangle, you see an orange square and a green square and a purple square. And I can slide the orange square into the purple, and then each of these little squares will fit perfectly into that purple square. So that's why leg squared plus leg squared is equal to the hypotenuse squared. Even if you had a bigger triangle, as long as you have a right triangle, again, I can slide that orange into the purple, and then all the little green squares fit perfectly in there. So that's where leg squared plus leg squared is equal to hypotenuse squared comes from. Let's look at a couple examples. I always like to label the side across from the 90 to be the hypotenuse. Let's look at a couple examples. I always like to label the side across from the 90 to be the hypotenuse. So for this example, I could say 6 squared plus b squared is equal to 10 squared. 36 plus b squared is 100. Take away 36 from both sides. B squared is equal to 64. B squared is equal to 64. So b is equal to the square root of 64. Now technically from Algebra 1 it's plus or minus, but we're talking about distances, so it has to be the positive, so we get 8. Let's take a look at number B, or letter B. Again, I'm going to label across from the 90 is the hypotenuse. So 7 squared plus 24 squared is c squared. 49 plus 24 squared on your calculator is 576. Adding those two numbers up, you get 625. Take the square root of both sides, and you get c to be 25. Let's take a look at a couple examples on the second page. If you look at problem number 1, again, I like to label the hypotenuse. So across from the 90 is the hypotenuse. So 7 squared plus 8 squared is equal to x squared. 49 plus 64 is equal to x squared. And when you add those two numbers up on your calculator, you get 113. So 113 is equal to x squared. So x is equal to the square root of 113. 113 does not have any perfect squares, so we're going to leave our answer like that. If you look at problem number 2, again, across from the 90 is the hypotenuse. So I'm going to say 9 squared plus x squared is equal to 12 squared. A common question is sometimes can you say x squared plus 9 squared is equal to 12 squared? And the answer to that is yes. Either equation will work. So x squared plus 81 is equal to 144. Subtract 81 from both sides. And on our calculator, we will get 63. So x squared is equal to 63, which means x is equal to square root of 63. Now 63 breaks down. 63, if you think about 9 goes into that, so it's 9 times 7. And then the square root of 9 is 3. So you get 3 square root of 7. My suggestion is you pause the screen and try problems 3 and 4 and then come back. So let's take a look at problem number 3. Again, labeling hypotenuse is x, so here's the main equation. I'm going to get x is equal to the square root of 170. When I think about two numbers that multiply to 170, I get x is equal to the square root of 17 times 10. Neither of those are perfect squares, so the final answer is here in blue, x equals the square root of 170. For problem number 4, main equation, x squared plus 7 squared is equal to 11 squared. Simplifying that, you get x equals square root of 72. I like to find the largest perfect square, which is 36. So it's 36 times 2, and then the square root of 36 is 6. Some of you may not recognize that, so some of you may say, oh, I know that is 9 times 8. Then you may say that's 3 square root of 8. And then there's even a further step after that. You may recognize that 8 is 4 times 2. So then x is equal to 3 times 2 square root of 2, because the square root of 4 is this 2 that I'm highlighting in yellow. And then when you simplify, you get x to be 6 square root of 2. My suggestion is you pause the screen, try problems 5 and 6. So let's take a look at how you did on problems 5 and 6. So for number 5, the hypotenuse is x, so this is the main equation highlighted in green. Going through the algebra, you get x equals square root of 128. 128 breaks down to 64 times 2, and then the square root of 64 gets you the final answer of 8 square root of 2. If you look at problem number 6, main equation, x squared plus 4 squared is equal to 10 squared. Simplifying, you get x equals the square root of 84. I know that 4 divides 84, so I wrote it as 4 times 21. And the square root of 4 is the 2. So the final answer for problem number 6 is x equals 2 square root of 21. So I hope you found this video helpful on the Pythagorean theorem.